Module 4, Lesson 20, Writing and Evaluating Expressions, and this time looking at multiplication and division. Learning target, show and explain relationship between the operations. We are looking at relationship between operations, in particular that multiplication and division are inverse operations. We are going to be representing real life situations. In particular, we're going to be looking at tables and figuring out the expressions. The tables will be based on some real life situations. A tiny bit of experimentation going on, doing some substitution and seeing what happens with expressions. I can statements. I can represent real life situations by writing expressions with variables. So our expressions will have variables, and they will also have multiplication and division. Going to use substitution. So substitute a value in for the variable and evaluate the expression and see what we get. And then we are looking at a table of values and writing an expression to show the relationship. All right, quick review from yesterday. What patterns do you see on the table? And there are a variety of patterns. As we go from the my age to the sister's age, we are adding 2, and that is a fixed relationship. On each one of the rows, we add 2. To go from the sister's age to the my age, we are subtracting 2. Students may also have noticed or observed that we are adding 1 as we go down the rows, and that we are subtracting 1 as we go up the rows. So an important question to consider when looking at all of these different patterns is which of these patterns is the most powerful or useful for us to pay attention to, because they're all good patterns to observe. Some students might say it's very useful to notice the up and down patterns, the adding 1 and subtracting 1. And the question I would pose is which one is going to give us the greatest amount of flexibility? If I am using these horizontal patterns, going from the right to the left, from the left to the right, and the right to the left, I can pick any value that I want for the my age and for the sister's age and figure the other one out. So I'm going to suggest that the relationship between the columns, this left and right stuff, is more powerful than the vertical, the going up and down stuff. Because I can pick any age I want. I can say that the my age is 78, and I add 2 and know that the sister's age is 80. I can say that the sister's age is 96, subtract 2, and know that the my age is 94. And I can find out that information without extending the table. So as we're looking at patterns, I want you asking yourself, what is the most powerful pattern, the pattern that is going to give me the greatest amount of flexibility to work with the information that I have? All right, so taking a look at example 1 here. The farmer's market is selling bags of apples, and in every bag there are 3 apples, and we are asked to complete the table. Now, I would like to point out that this is a ratio relationship. In every bag there are 3 apples, so we are working with the ratio of 1 to 3, which is a multiplicative relationship. The number of apples is 3 times the number of bags. So I could look and say, hey, we're adding 1 as we go down this, and hey, we're going to add 3s as we go down this, but that's not the most powerful relationship. That's not the most flexible relationship, especially when we get down here and we say, oh, it's a variable b, it's not a 5 in that row. So we are scaling here. So we have doubled and doubled, and we have tripled and tripled, and we have quadrupled and quadrupled. So that's using the vertical relationship of the ratio table. However, I would like to step back and get back to the idea of the ratio relationship of 3 times. We are multiplying by 3 as we go left to right. I'm going to multiply 2 times 3 and get 6. I'm going to multiply 3 times 3 and get 9. I'm going to multiply 3 times 4 and get 12. And I'm going to multiply b times 3. Rather than working vertically, looking for the powerful relationship that we have between the columns. And if the market had 25 bags, see, this is where it becomes powerful. I don't have to continue to work down one row at a time. I can just say, hey, I'm going to work with my expression b times 3. I'm going to substitute 25 for the number of bags, multiply by 3, and find out that there are 75 apples in 25 bags. So looking for the relationship between the columns. So I'm going to suggest to you that don't let yourself get fooled when they do a nice plus 1, 2, 3, 4, stuff like that. In a moment, we're going to look at the relationship between the columns coming back, so going from the apples to the bags. All right, b is 25, then 3b equals 3 times 25, which is 75. So a truck has arrived, and that truck had some more apples on it. And the question is, how many bags would I need? And we are right now going to look at that division side. We're going to be looking at going from apples to bags. Now, how did I know that that was a division operation? Well, if the relationship going this way is multiplication, the relationship going this way is the inverse operation. It's division. You'll remember that we looked at this with the addition and subtraction. In the last lesson, we were adding as we went left to right and dividing as we went right to left. So if I have some apples, and I'm going to do a model here, I've got some apples, and I'm going to put them into groups. Now, how many go in each group? 3. We saw that on the table. So I'm just going to go through here and build a bunch of groups of 3. So I'm going to take the apples, and I am going to divide them into groups of 3. So I'm going to need A divided by 3 number of bags. How many groups of 3 can I make out of these apples? And it's interesting, if I have a multiple of 3 for the apples, in other words, if it divides evenly, I won't need any extra bags. I won't need any more bags. If I've got 1 or 2 apples left over, I'm going to need an extra bag. So A divided by 3 bags are needed. And if there are 1 or 2 apples left over, an extra bag is going to be needed. Although the bag's not full, but we're not going to let the apples just sit there and rot. We'll give somebody a 1/3 or 2/3 price. Now, if the truck arrived that had 600 apples on it, how many bags would I need? Well, I have my expression that I've written right here. I'm going to take the apples, put them into groups of 3. Well, 600 divided by 3 is going to give me that I need 200 bags to take care of the 600 apples. Well, now the question is here, how is part D different than part B? So here's our part D that we just did, and here's our part B that we started with. And you'll notice in part B that we were performing a multiplication operation. And in part D, we were performing a division operation. They're inverses of each other. To get from the apples to the bags was division. We had to put the apples into groups. To get the bags to the apples, we were performing a multiplication operation. We were counting up all the little apples within the bags. So part D gives the number of apples and asks for the number of bags, and part B gives the number of bags and asks for the number of apples. Inverse operations. In New York State, there is a 5-cent deposit on all carbonated beverage cans and bottles, and when you return the empty can or bottle, you get 5 cents back. And the first question we have here is, let's complete the table. So if we return one container, how many dollars are we going to get? Well, we have to think about what is 5 cents in comparison to dollars. 5 cents is 5/100ths of a dollar, which is 5/100ths. So 1 is going to get us 5/100ths. And for 2, then I'm going to double 10 cents. But see, now I'm working vertically. I really need to, in my head, remember that I am working with this relationship this way. So 3 times 5 cents is going to give me 15 cents. And 4 times 5 cents is going to give me 20 cents. And 10 times 5 cents is going to give me 50 cents. And 50 times 50 cents is going to give me $2.50. And 100 is going to give me $5. And so for the expression here, I'm taking however many containers I have and I am multiplying them by the 5/100ths. Notice that I'm really focused on using the relationship going this way. And there is my expression down here at the bottom, 5/100C. And the question, of course, would be, how much would I receive if I returned 222 cans? And it says use the expression. I know there are other ways to do this, but they want us to use a little substitution here. 222 times 5/100ths. Well, I know that these are all 2's multiplied by 5. So I'm going to have a 10, and a regroup, and an 11, and a regroup, and I've got an 11. And the decimal is going to move 2 places. And I'm going to find out that I would get $11.10. And that's what's hidden underneath all of my writing here, $11.10. Now it says Gavin needs to earn $4.50 for returning cans. Now the first problem we looked at, we were given the number of containers and we were figuring out the refund. Well, now we are getting the dollars that we want and going the other way to figure out the containers. So what operation are we going to need to perform? Well, we were multiplying as we came this way. So what is the inverse operation? Well, going back this way must be division. So I'm going to take the $4.50 and I'm going to divide it by the 5 cents. And the decimal can move 2 places, I've got 450 divided by 5, and that's going to give me 90. He's going to need to collect 90 cans if he wants to get the $4.50. Once again, I want to emphasize, point out, that I am thinking about the patterns and relationships within the table. Going this direction was multiplying, going this direction was division. Now it's at this point that we not allow ourselves to get fooled and think, oh, it's always multiplication when we go left to right, and it's always division when we go right to left, because that's not true. Sometimes they'll be tricky, and you will have to divide when you're going left to right and multiply when you're going right to left. So it's important that we don't develop any false sets of rules, and what we actually do is examine the relationship on the table and ask what is happening. All right, so taking the comparison of parts D and C, well, C was a multiplication expression, and D was a division expression. They're inverses of each other. To get from the containers to the refund, I was multiplying. To get from the refund to the containers, I was dividing. They're inverse operations, which is, of course, one of the reasons we spent all this time looking at the relationship between operations. All right, the similarities between example 1 and exercise 1. Well, example 1 and exercise 1, we're working on the relationship between multiplication and division, which are inverse operations. When we look at lesson 19, we were using addition and subtraction, and we were looking at the inverse operations. So in this lesson, we've got a multiplicative relationship. Multiplication and division are a multiplicative relationship. Fixed relationship is to multiply or divide by a constant value. Our constant value for the containers and the refunds was 5 cents. In lesson 19's tables, we had an additive relationship, and the fixed relationship was to add or subtract a constant value. Inverse operations all over the place, and they're powerful. All right, taking a look at the fare for a subway or a local bus ride, and we're going to say that the fare is $2.50. So one ride is $2.50. Now, looking at this as a ratio relationship, 1 is $2.50. So 2, I have a doubling going on here. $5. And then I've got 3 times $2.50, which will get me $7.50. And I've got 4. This is a rate. 4 of them would be $10. 5 of them is $12.50. 10 of them is $25. 30 of them. 30 times $2.50. Well, that's going to get me $75. And I've got $2.50, and I am multiplying that by the number of rides. So complete the table, and then here is my expression here. Notice that I used the relationship between the columns as I worked this problem. So the question is, how much would 60 rides cost? And it says to use the expression. I know that there are ways we can use our scaling, like right here we just double this, but let's use the expression. Let's do the substitution. So $2.50 times 60. No, I don't need the 0, add in the hundredths place there. I'm going to run out of room here. That's okay. And I find out that it's going to cost $150. 60 rides is going to cost $150. So we have worked going from, I've got to change the titles on the table here. We have gone from the number of tickets to the price. Well, now we're turning around and going the other way and saying we have the price. Let's find out how many tickets. If we were multiplying going left to right, what is the inverse operation? Aha! We are dividing. Oops. We are dividing. So I'm going to take the amount of money and I am going to divide it by the constant. All right, move the decimal, bring the decimal up. There we go. So 1,750 divided by 25. Well, to get to 175, 4 25s gets me 100, and so 3 more will get me to 175, so that makes 7 of them. 7 times 25 is 175. Subtract. So for $175, we can get 70 trips. Notice that I used the pattern within the table to help me answer that question. And buried underneath my beautiful scrawl, yes, that's sarcasm. 175 divided by 250 is 70. The commuter took 70 trips. All right, so once again, comparison here. Well, we had a multiplication expression, and then we worked the inverse for division. So they gave us the amount of money, asked for the number of rides, so we divided. They gave us the number of tickets, so we multiplied. All right, this is a challenge question. I am not going to show you this one. I want you to puzzle and struggle with this. If you're dying to know the answer, check out the teacher materials that are included on the website. Oh, the answers are going to roll across here, but I'm not going to explain them. You'll have to figure those out yourself. All right, in example 1, we looked at the relationship between the number of bags purchased at the farmer's market and the total number of apples purchased. We created two different expressions, 3b and a divided by 3. 3 times the number of bags and a divided by groups of 3 apples. What does each variable represent? Well, the b is the bags, the a is the apples. We multiplied by 3 in the first expression because each bag had 3 apples in it. So there were groups of 3 and we were counting all of those. In the second one, we divided by 3 because we had a big pile of stuff and we were actually grouping it out into groups of 3. B represented the bags, had to multiply by 3 because we're given the number of bags and there are 3 in each bag. Variable A represented the number of apples. We divided by 3 because we were given the number of apples that needed to determine the number of bags needed. What would the expressions be if the farmer's market sold bags that contained 5 apples in a bag instead of 3? Well, I would take the apples and put them into groups of 5. 5 in each bag. I'd multiply 5 times B to determine the total. All right, wrapping up the lesson here. So hopefully you are starting to feel comfortable about real-life situations with variables and the operations of multiplication and division. And we did some substitution, at least if we used the expression like we were supposed to. And we analyzed tables and looked for an expression to represent that relationship within the table. All right, relationship between operations, really emphasized inverse operations, nature of multiplication, division, addition, subtraction, that relationship. Real life situations, we determined mathematical expressions based upon the values given on the table. Did a little bit of experimentation. We had some what ifs. What if there were this many apples? What if there were this many bags? So that concludes Module 4, Lesson 20. If you have any questions, make sure you get with your teacher and make sure you complete your problem set.